So today we are going to study this stability for this dam. So generally these are, we can say, failure criteria for the dam. The dam is liable to fail by these four criteria. First one is by sliding on the soil on which it is rest. Second one is by overturning. Third one, due to the tensile stresses develop. And fourth, due to the excessive compressive force. So these are the four causes for the failure of dam that we are going to study. So first one, sliding. So generally the horizontal water pressure is acting over the dam, which tends to slide the dam over the soil on which it is rest. But whatever the frictional resistance develop, it try to resist this sliding force. Now this sliding resistance, whatever the frictional resistance develop, it will be equal to mu into W. So this is the frictional force that we have already seen in strength of material. So this frictional resistance is mu into W. Generally it is, this frictional resistance is generally F will be equal to mu into N, but for the case of dam, N will be equal to W. Normal force will be equal to downward weight, so N will becomes a W. So F will be equal to mu into W in this case. Mu is what? So here in this case, mu is the coefficient of the friction. So here in this case, what is mu? Mu is nothing but the coefficient of the friction. So this is the frictional resistance. So if this sliding force is less than this frictional resistance, so what? This frictional resistance is more than this sliding force, then dam will be a safe in the sliding, we can say. So this ratio of these two force, that is frictional resistance divided by sliding force. So this ratio, that will be known as a factor of safety. So this ratio is known as a factor of safety against the sliding. And so as per the structural design consideration from IS 456, this ratio must be greater than 1.55 for the dam to be a safe in sliding. Okay, so let's see another criteria, that is overturning. In order that the structure may not overturn, it is necessary that resultant must be passed within the middle base. So generally what happen, this, let us consider it is a dam and the water pressure is acting over this dam. This water pressure try to overturn this dam. So this water pressure try to overturn this dam about this point, and this point is known as a toe for the dam. So this point is known as a toe for the dam. So this water pressure, let's say it is P. So this water pressure P try to overturn the dam about this toe point, and that's why dam may overturn. So we need to check the safety against this overturning. So for that purpose, the whatever the resultant force acting over the dam, so generally we have already seen in previous lecture, the pressure P is acting, the weight W is acting downward. So resultant of these two forces must be pass within this middle base to have the safe against the overturning. So to have the safety against the overturning, it should be passed between the middle base. So if the dam total width is b, then it will be divided in three parts: b by 3, b by 3, b by 3, and our resultant force must be passed within this middle base to have the safety against the overturning.